Okay, today we're going to be solving systems of equation using elimination. Last week we used substitution, which is basically solving from one of the variables in one of the two equations, then substituting that value into the second equation to get a variable equal to a value, and then simply plugging that back into either equation to get the full coordinate point. Today we're going to be using a process called elimination, which from experience has been the one that most students tend to use. What we'll try to do here is we're going to multiply one or both equations by a number to produce the same or opposite coefficients for a variable. What that means is we're going to try to get these equations to either have opposite coefficients or the same coefficients. All right. Then we're going to proceed with elimination, which I will go through as we go through the first one. Now, this first one here is a good example of us trying to eliminate variables. Because remember, we're using elimination. That means we want to eliminate a variable so that we can hopefully be left with a variable equal to a number. So if we take a look at the first equation, okay, I have 2x and negative x, okay? So I do have one's positive, one's negative, but one has a 2 on front, the other one has an x front. In order to use elimination, these both have to have the same coefficient. It's okay if they have different signs or the same signs, but we want them to have the same coefficient. For instance, take a look at the y's here. Both of them are 4s, okay? Both of them say 4. Now, the question is, how are we going to combine these? Well, since they have opposite signs, all right, we would add them together. And this is normally the path I take. Most students tend to, instead of jumping back and forth, they're either going to always try to make sure that their two equations have opposite, or the two variables have opposite signs, or make sure that they have the same sign. The only thing that matters is, since we have opposite signs right here, we're going to add these two equations together, because if I add negative 4 to 4, I'm going to get 0. Now, if I would have subtracted, I would have negative 4 minus 4. That would have given me negative 8. Because remember, the goal of this is to have one of our variables cancel out. All right? I tend to always try to get opposite signs but the same coefficient, like this. That way I'm always adding. It's usually easier to add things together. So now if I go down the line here, I have 2x plus a negative x, which is just simply 2x minus x. Okay, just leaves us with a single x value right there. And as I said before, negative 4y plus 4y, those are actually going to cancel out, leaving us with 2 plus 3 at the end here, and that is equal to 5. All right. Now, sometimes we might end up with like a 4x or whatever down here, in which case we just have to work to get the x by itself. Okay. So once again, this whole goal here is us to get the answer as a coordinate point. Okay, the solution of the system equation. So the x value is 5. So now what we need to do is take what x equals and plug it into one of the two equations, okay? It does not matter which one we plug it into. I'm just going to go ahead and plug it into the second equation here. Okay, so I'm going to take this second equation and I'm going to plug x is equal to 5 in for it. So that's going to leave me with negative x, which is also negative 5, plus 4y is equal to 3. Okay, now all we have to do is get y by itself. So we're going to get rid of negative 5 by adding 5 to both sides, in which case we're going to be left with 4y is equal to 8. Then finally we're going to get rid of times 4 by dividing by 4. That's going to leave us with y is equal to 2, which is our y value, which is how we end up there. Now this one is a very easy one because we already had opposite coefficients. Okay, now we take a look at the next one here. Look at my x's. And this also brings up another point. If your equations aren't set up the same way, it's going to be best to go ahead and get up the same way. And this is standard form for the most part. X's and Y's on one side, variables or numbers on the other. All right. So now what we need to look into is, what can I do to one of these two equations, or both of them, so that I can get one of my variables to eliminate. Okay. Now usually if you have a variable by itself like this is typically going to be the easiest one, because if this is y and I need to make it look like a 2y, but the negative form, I try to think, okay, what can I multiply y by to give me the opposite of 2y? Okay, now if I multiply that by negative 2, okay, negative 2 times y gives me negative 2y, then I'm going to have opposites. Okay, now the only thing is we do have to distribute this negative 2 throughout the entire set of parentheses. So negative 2 times 4x is negative 4x, negative 2 times y is negative 2y, and negative 2 times 23 is negative 46. Okay, because remember the goal was to eliminate the y's in this one. So look, negative 2y and 2y, I'm going to have them eliminated. Now we're not going to multiply the bottom equation by anything because we only need to multiply the top by something to eliminate the y's. Now, if we wanted to eliminate the x's, we would have multiplied both top and bottom by some, but we'll get into examples like that later on. Since I didn't multiply the bottom by anything, we're just going to go ahead and rewrite it. 3x plus 2y is equal to 37. Okay? And once again, since I have opposite signs, we are going to add them together. That's going to leave me with negative 4x plus 3x, which is a negative x. Negative 2y plus 2y cancels out. Then negative 46 plus 37 equals a negative 9. Okay? In which case, we do have a negative in both of them. Easiest way to get rid of a negative is just divide both of them by a negative. In which case, we're going to be left with x is equal to 9, which will be the x value there. Okay? Now, once again, we've got to choose one of our two equations to plug x equal to 9 back in. And I usually typically go back to one of the two original equations, okay, because sometimes we might mess up something over here. And plus, we ended up with bigger numbers over here because we multiplied this by -2. So what I'm going to do is I'm going to take the first equation here, and I'm going to plug in x equals to 9 for it. Okay, so that's going to give me 2 times 9 plus y is equal to 23. 2 times 9 is 18 plus y is equal to 23. And finally, to get rid of an 18, we're going to subtract both sides by 18. That's going to leave us with y is equal to 5, which would be our answer there for the y coordinate. That would be our solution for that system of equations. All right. All right, we do have 3 more here. You want to pause the screen and try these ones on your own, you can. All right. Once again, for these, what we want to do is we want to get opposite coefficients, okay? Now, some people tend to look, all right, I already have opposites here, so maybe that's going to be easiest. So maybe we eliminate the y's again. Now, we could very well eliminate the x's, but we would have to have one of them be multiplied by a negative. Now, 3 and 4 and 5 and 3, doesn't matter which one we choose, we're going to have to multiply both equations by some, but they have to be different. So we try to think, what can 3 and 5 both go into here? 3 and 5 can both go into 15. All right? Now, if I want this to say 15y, I'm going to have to multiply by 5. If I want this one to say negative 15y, I have to multiply it by 3. Okay? And what we're going to do here is we're just going to write our answers down here. So I distribute the 5 in the top one. 5 times 4x is 20x. 5 times 3y is 15y. 5 times 8 is 40. Okay, if I distribute the 3 on the bottom one, 3 times 3x is 9x. 3 times negative 5y is negative 15y. And then 3 times negative 23 is negative 69. Okay? Now, next step is like we did before. The y's are opposites, so we're just going to add the first to the second. So we have 20x plus 9x gives us 29x. 15y plus a negative 15y cancels out. 40 plus negative 69 gives me a negative 29. Okay? In which case, to get rid of the times 29, we will need to divide by 29. 29's cancel out, leaving us with x is equal to negative 1, which is the x coordinate of our coordinate point. All we have to do is take negative 1 and plug it back into one of the two original equations. I'm going to choose, doesn't matter which one, I'll choose the first one here, okay? So I would have 4 times negative 1 plus 3y is equal to 8. Okay, just simply plug in the negative 1. So it'll give me negative 4 plus 3y is equal to 8. Get rid of a minus 4 by adding 4 to both sides. In which case we're left with 3y is equal to 12. And finally get rid of a times 3 by dividing by 3. And we're left with y is equal to 4, which would be our y coordinate there. Okay. All right, take a look at these next ones here. See what happens. All right, once again, we don't have a little bit of a luxury of easier ones here, so we have to, let's eliminate the x's on this one, because this might be easier. So we try to think what can go into, what 3 and 4 can both go into, and they both can go into 12. When in doubt, you can always just multiply the numbers by one another. So you multiply the first one by 4 and the second one by 3, and it's still going to work. There just might be an easier one to get before you get to that point. So if I distribute the 4 to the top one, I get 12x for the first part. 4 times negative 6y is negative 24y. And 4 times 40 is, 4 times 10 is 40. Distribute the 3 to the bottom one, we get 3 times 4x, which is 12x. 3 times negative 8y is negative 24y. Okay? And 3 times 12 gave me 36. Okay? Now you'll notice in this one, all right, I did it the other way. Okay, which means instead of trying to get them to be opposites, I ended up having them be the same. Now I could have very well, and I probably will go back and fix this real quick. If I would have distributed a -4 throughout the top set, that would have given me a -12x there. That would have given me a +24 in the middle and a -40. I'll stay consistent with the path that I've been choosing. Okay. Because remember, we wanted to have opposite signs. So now we have that. We can add these two equations together. But we will notice something different happens here. -12x plus 12x cancels out. 24y plus -24y cancels out. That leaves us with 0 is equal to -4. Okay? So in this case, we have no solution because that is obviously a false statement. So we ended up with parallel lines for this given example. Okay? So once again, when we have no solution, we have parallel lines. Now let's see what this next one turns into. All right? Now we're back to, I think the first one will be able to multiply by something. Let's go ahead and distribute. Okay, let's see what we can multiply. 2x to make it look like 10x. Well, we can make it look like 10x by multiplying it by 5. We'll multiply it by a -5 to ensure we have opposite signs. So if I distribute the -5 to the top, I get -10x, -5 times 4y is -20y, and -5 times 8 is -40. And we didn't multiply the bottom equation by anything, so we'll just go ahead and rewrite it. And as you go to rewrite it, you might notice something else when it comes to this one, especially when you go to add them together. When I add these together, the x's cancel, the y's cancel, and the constants cancel, leaving us with 0 is equal to 0. Once again, that's a true statement. That's a true statement there, which means here is another example of infinite or many solutions. Basically meaning we have this exact same line on top of one another. Okay? So once again, when both of them cancel out, we end up with a false statement and no solution. When they end up with a true statement, it has infinite many solutions. And once again, when you don't have both variables cancel out, remember, every time we should have at least one variable cancel, and that's why it's a little bit easier process here to get to our answers. All right. All right, that's going to conclude this section of notes. Make sure to complete the assignment to reach the goal it needs to be. And as always, if you have any questions, send me an email.